So the dividend discount model when dividends grow at a constant rate. So suppose the dividends of a company grow at a constant rate represented by the letter small g here. So we have D1, D2, D3, D4, D5 into perpetuity. D2 is 1 plus g times D1. D3 is 1 plus g times D2, which is 1 plus g times D1. So that gives us 1 plus g squared times D1. D4 is 1 plus g times D3, which is itself 1 plus g squared times D1. So that gives 1 plus g to the power 3 times D1. D5 is 1 plus g times D4, which is itself 1 plus g squared times D1, which gives 1 plus g to the power 4 times D1. Okay, if we know D0 and g and D1 is equal to 1 plus g times D0, then every dividend is just 1 plus g to the power its own time period times D0. Okay, so if our starting point is D0, D1 is 1 plus g to the power 1 D0. D2 is 1 plus g to the power 2 D0. Okay, so the numbers that add up is D0, like the subscript to D, plus the power to which that we put for that we use for 1 plus g. So 0 plus 3 is equal to 3. 0 plus 4 is equal to 4. 0 plus 5 is equal to 5. Whereas here, 1 plus 3 was equal to 4. 1 plus 2 was equal to 3. 1 plus 1 was equal to 2. So the price of a stock with a dividend that grows at a constant rate g is equal to this equation here. So P is the present value of all future dividends. So if we replace D2 by 1 plus g D1, D3 by 1 plus g squared D1, and so on. So we obtain the price for the stock is D1 over 1 plus RE times 1 plus g over 1 plus RE plus 1 plus g over 1 plus RE squared, and so on. So we need to solve, in order to have a closed solution for P0, we need to find a formula for whatever we have in parentheses here. So what we have here has a closed form solution only if g is smaller than RE. If g is greater than or equal to RE, then this summation here, 1 plus whatever squared plus whatever to the power 3, is infinite. The only way this summation here has a finite solution is if 1 plus g is smaller than 1 plus RE. In order to have here values smaller than 1 and smaller values smaller than 1 to high powers converge to 0. So if g is greater than or equal to RE, this summation S goes to infinity. If g is smaller than RE, then we will be able to find a finite solution or a closed form solution for the summation S. So assume that g is strictly smaller than RE. So what is the value of S? So from the equation, S is equal to 1 plus this summation of a term here that always gains 1 unit of power. So take S, subtract 1. So S minus 1 is the sum of this character that always increases by 1 power. So we have these two terms here. So S minus 1 is equal to this summation here. And 1 plus G over 1 plus RE times S, if you try it here, gives you the same solution. So S minus 1 here is equal to 1 plus G over 1 plus RE times S. Okay, look at these equations carefully. So I have S is equal to 1 plus term plus term to the power 2 plus term to the power 3 plus term to the power 4 and so on. So S minus 1 is equal to term plus term to the power 2 plus term to the power 3 and so on. And if I take this S and I multiply it by 1 plus G by the term. Okay, so term times S is equal to term plus term to the power 2 plus term to the power 3. So S minus 1 is equal to 1 plus G over 1 plus RE times S. Okay, so these two terms here are equal. We just have the same value on the other side of the equality sign. So S minus 1 is equal to 1 plus G over 1 plus RE times S. So then we can solve for S. So from there, if we isolate S, we obtain S is equal to 1 plus RE over RE minus G. So just playing around, okay, with this equality here and putting S on the left hand side of the equality sign gives us S is equal to 1 plus RE over RE minus G. So whatever G is strictly smaller than RE, the summation 1 plus G over 1 plus RE plus 1 plus G over 1 plus RE to the power 2 plus 1 plus G over 1 plus RE to the power 3 and so on into infinity is equal to 1 plus RE over RE minus G. Since P0 is D1 over 1 plus RE times the summation we just solved, so we replace that summation by the solution we just found. This gives us the price at time 0 is D1 divided by RE minus G. So it's simply the present value of a growing annuity, for which the first payment will be D1. An example. Castor Mining is expected to pay an annual dividend of $1.70 1 year from now. After next year, Castor Mining's dividend is expected to grow at the rate of 1.9% per annum forever. If Castor Mining's equity cost of capital is 9.3%, what should its current stock price be? Next, dividend 1.7, cost of equity capital 9.3%, growth rate 1.9%, so the current stock price should be $22.97. Castor Mining has just paid its annual dividend, which was $1.4. If Castor Mining's dividend is expected to grow at the rate of 9.8% forever, and the company's equity cost of capital is 14.7%, what should the company's stock price be? So D0 was 1.4, but it's been paid yet. So it's not in the current price. The current price does not include D0 because D0 will not be received by someone purchasing the stock today. So for someone purchasing the stock today, the next dividend is 1 plus G times D0. So 1.098 times 1.4. So P0 is D1 over RE minus G. D1 is 1.098 times 1.4. RE is 0.147. G is 0.098. So that gives us a price of $31.33. What can we say about the total return on a stock investment in the case of a growing dividend. So if we rearrange this equation here, we obtain the total return is the dividend yield plus G. So RE, the expected return on the stock, so the cost of equity capital, is equal to D1 divided by P0, which is the dividend yield, and plus G, which is the return the investor obtains arising from growth opportunities of the company. So the reason why there are growth opportunities for this company, it's because not all its earnings are paid out as dividends. So some of the earnings are reinvested into new projects. These new projects provide growth to this company. So these new projects increase the earnings the company can realize each year. So the total return realized by an investor is equal to the dividend yield plus growth opportunities. Okay, these growth opportunities, where do they come from? This is what we will see in the next video.